Okay. Hello everyone and good evening. I'm Jacob Kirera. I'm the main lead for this cohort. Today the team and I seemed it fit to give you a general introduction to programming because we know that we have people from different backgrounds in our midst. We have the medical guys and we have the engineering uh, people too. So we not want to start off the challenge assuming that everyone is from a tech field. So for the engineers, you can do more. Maybe this is kind of a refresher for you guys, but for the medics, we are going to work with you here. So in case something is not quite clear, you can just leave something in the chat or raise a hand or just unmute and ask the question as we go by. So the objective for this session, Introduction to Programming, is to help you know, and define what programming is and its purpose, get to know the core programming concepts as a general overview. Then you can identify the key features of Python and its suitability for ML. I think this is going to be covered in a later session. Today I resorted to give you a general overview of programming at its core. Okay. So why is it relevant for you to know how to program in its sense? So in our case, we are in the ML summer school, so we are going to build and train our machine learning models. So by virtue that we are training and building the model, you should know a little bit about, you should know how to program your programs. I will be fine-tuning and optimizing your models. This might seem a little bit some techy jargons, but we're going to understand what we mean by fine-tuning and optimizing later. Then we're going to implement our models in real-world applications. So programming is the key that will just allow us to unlock the full potential of our ML vision. So if we were to define what is programming in its essence, so programming is the process of basically just designing, writing, testing, debugging, and maintaining the source code of computer programs. We'll see what a sample program looks like. It just involves you create a set of instructions that tell a computer to what to perform a specific task and maybe how to solve a problem. So it's like I gave a little analogy here. It's like programming is like writing a recipe of a robot chef. Number one, a programming language is the language of the recipe. It can be English, French, Japanese. So when you say we're going to teach you about Python programming, it's just one of the languages that you use to give your computer the instructions. It can be, there are many languages, over 700, but we are going to use, in our case, one of the languages, Python. So when I talk about the code, I'm talking about the steps in that recipe. That is the code. It's a set of detailed instructions you write to tell the robot exactly what to do. Okay. Pick up the pen, move it to the left. Those are the instructions. So when you're doing programming, you put that in code. That's our code. Okay. Then our algorithms is just, in our case of a robotic chef, it's just the cooking process. The algorithm is what is the overall plan of how the meal will come together. The steps that from the beginning, chopping those ingredients, adding your spices, marinating it, and that's more or less the algorithm in our case. Then we have debugging. Basically, this is just fixing a bad recipe. If food doesn't taste right, example, you cooked it, it's undercooked, or it does not have any salt, you might tend to add a pinch of salt. For our case in programming, you will figure out what went wrong and try to sort it out. You are getting some errors. You're basically trying to identify where the problem is and fixing those errors in your code. Then execution is basically where you just decide to cook the dish. Is there a question? Okay, you can proceed. So once the recipe is ready, the robot chef follows the steps to create the dish, just as the computer will follow the code to run the program. You have come with the algorithms, the code, the necessary steps on how to cook some particular meal. So the robot chef will, okay, this is what I've been told, this is how this is done. it does follows those steps and finally executes, cooks that dish. Okay. So relevance of programming, as with any other thing, tech and everything, we use it to build technology. You, as a programmer, you can build websites, mobile apps, video games, tools like Google Maps, Instagram, TikTok, and so on. You can use it to solve problems, real world, like finding the fastest route to destinations, to help doctors diagnose diseases. Okay, we can even automate processes like sorting emails or analyzing data, which helps to save time and effort. Of course, there's a lot you can do with programming. This what we are doing right now, AI, virtual reality, there's robotics, and so on. So a little bit of a history of programming. So when did it all begin? So the roots of programming traced back to the early 1800s with the invention of the Jacquard loom. This guy used punch cards to control the weaving of patterns in fabric, basically clothing and so on, making it one of the first programmable machines. So of course, from there, it was all about iterating and so on. From the basic, it's like the Newton law. From the three laws, we now have aerospace engineering. It's going okay. Okay, so in the now we have discovered that Jacquard loom came with those punch cards in the 1800s, and then came a very visionary girl. We even have an IEEE day. Okay, IEEE in full stands for Institute of Electrical and Electronic Engineers. We'll cover that later. There's this lady in the mid 80s, Ada Lovelace, became known as the first computer programmer. She collaborated with the guy we call Charles Babbage in his design for the analytical engine. Of course, she wrote the first algorithms intended for machine and demonstrated the potential of the computers to go beyond basic calculation, because most of the things that they used to do before was just abacus, adding plus and minus currency and so on. This is a very significant lady in the programming field. Maybe you can look at her later. We even have a language named after her called Ada. We use it to program our satellites, and mostly it's used for the military, for the guys for the Ministry of Defense and so on. They use it to program their hardware there. Okay. Then now we are in the modern age, the modern computing era. We're in the mid 20th century. We saw the advent of electronic computers such as the ENIAC, UNIVAC. Okay, I'll leave this notebook to you, can explore that further. That's where we started to get languages, other languages now coming up, assembly at the higher level. We had the Fortran, COBOL, and Python, Java, and many others. So now we get to the programming languages. How do you talk to the computer now? So programming languages are just the tools we, the developers, use to communicate our instructions to the computers. There's the normal English as we are talking right now, but for the computer, you have to, there's a set of, a standard or a set of instructions, how you relay that information to that computer. You have to we can say some translator, meaning from the basic English to something there that converts what you want to, the idea you want to say to the computer, and gives it a format that it can understand. The languages, of course, have evolved over time, catering to different needs and enabling innovations across the industries. There are hundreds of programming languages. As I said before, we have almost 700. For this preview, I just picked the most common. You can, of course, go on your own and explore the other languages that are there. So maybe a little bit short history of how they developed. We have the common. Now, there's the high level, like the English we are talking about. Then you start going lower, lower, lower. The machine only understands the things in ones and zeros. So there's a language that's very, very close to the hardware, with the assembly language. By low level, we mean it's very close to the hardware. Then we have the high level, which is close to, okay, as you'll see, Python. I think the next time I'll give 2 shots of assembly and maybe Python so that you can see how this, the one is very low level, that the other one is very high level. Okay, then we have the Fortran 1957. It was used basically for scientific and engineering calculations. Then we have COBOL, created for business applications. At some point, even Kenya Power was kind of using this COBOL. Okay, so the modern, the most common ones right now in the market. Okay, we'll see later in the one you'll be sharing about the software engineering practices. There's what we call the maintaining that language, where after some time, if no one's making any updates to it, kind of or less becomes depreciated. Okay, so the modern programming languages we have is Python, the one we're going to start on January there. Known for its simplicity and versatility, it's a high level. It's more or less almost close to the normal English we know. It's used for web development, data science, AI, and more. Even for those guys who are doing hardware, there's some paradigm of its sort called MicroPython. You can even code your hardware in that space. Then we have JavaScript for front-end web development, Java. It's popular for back-end development and apps and large-scale application, and so on. We have C++. So I think the whole purpose of why I mentioned these things here, so that next time when you're going to start working on Python and we say, okay, this is more flexible than those other languages, you get to at least know that when you're referring to those other languages, maybe you're talking about C++, or Java or some sort. Okay. Of course, there are specialized language like R. You can also use R for ML, but that's a different story. Then we have MATLAB and SQL. So maybe basic concepts with regards to programming, because of course we are going to get deeper on our specific language Python later, but I'm just giving you an overall concept that apply to all languages. If you are to start learning maybe Java today and tomorrow go to R, there are some constant things that are going to cut across all these different programming languages. Number one, we have algorithms. So basically, an algorithm is a step-by-step procedure or other formula for solving a particular problem. In programming, algorithms are the foundation of writing efficient and effective code. So what are the characteristics of algorithms? They have finite steps. The number of steps there are known, because most of these algorithms are, you can have a problem, you start with the algorithms first before you get maybe to actualizing that problem. It's more or less planning to work on that problem. You start with the algorithm, then you can then proceed to code it. We'll see how that is beneficial. It must have a clear starting point and an ending point. It has well-defined instructions. Its steps must be precise and unambiguous. You should maybe see what that's, at one look at it, you know exactly what these things talking all about. Then we have input and outputs, where your program maybe takes an input, processes it, and produces an output to you. And effective, every step should be basic enough to be executed. No complexities should be involved in you when you're working, writing your algorithm. So why are they important in programming? They are efficient because they help programs write code that runs quickly and uses resources effectively. They provide a structured approach to solving problems, and they are very reusable. You see, once you have created an algorithm, you can just next time come for a different task, but is more or less in the same family, modify it a little bit, and it gets to sort you out. Okay, now for these types of algorithms, I think I've just mentioned it. I'll add a resource on this notebook so that you can explore them further. I've mentioned the few common ones. We have the sorting algorithm, which is just basically arrange data in a particular order. From the name, sort, bubble sort, quick sort, might sort. We have the searching algorithms. You basically use to locate a specific item in a data set. Then we have funny greedy algorithms, which make the best choice at each step to find the overall optimum solution. Okay, maybe that has gotten you worried a little bit, but there's the whole different set of session called data structures and algorithms. We will explore that further. Okay, So an example of an algorithm, example, you're making a sandwich. So your algorithm can be take 2 slices of bread. Number 2, spread peanut butter on one slice. Number 3, spread jelly on the other slice. Number 4, put the pieces of slices together. Then number 5, serve that sandwich, eat it. So when you're writing an algorithm in programming, here's how you might represent an algorithm, maybe, because for our case, we're going to learn about Python. I've used the Python example here. Example, we are writing an algorithm to find the largest number in a list. You have a list of 100 numbers. You want to find the maximum, okay, the largest number for that matter. So, okay, we'll dive into Python some. Just this is how you define a function in Python. You have the keyword def, then your function name is find maximum, then your parameters here. You have numbers, then you have maximum number is equal to numbers. Step 1, you assume the first number is the largest, of course. Yeah. Step 2, you iterate through the list. You have a list of 100 numbers. Go check the first number, the second number, the third number, the fourth number, the fifth, and so on up to get to the 100th number of your sort. Then compare each number with the current maximum. Then you update the maximum number if a larger number is found. Let's say you have from 1 to 10, you maybe, of course, from that list of 1 to 10, they might not be exactly 1, 2, 3, 4, 5, but you have in that list of 1 to 10, you have 20, 37, 43, 16, and so on. Maybe in that case, the largest number in your case would be 43. Then you have moved from 11 to 20, then you find maybe there's some 70 there. So automatically you update that the largest number up to that point it was 43, now it's 70, and so on. Then now after you have iterated up to the 100th number, you find the largest number in that case. Then you give us that output. Example, if you were to run this program. Okay, so we have our list. In our list example, we have 3, 7, 2, 9, 5. These are the numbers we have in our list. Our function is supposed to get us the largest number in this list here. So it has iterated over this list and gotten that 9 is the maximum number, and it has given us the output here as 9. So where is the real world applications for algorithms? We have the navigation system. We algorithms like Digistructures find the shortest path. Okay, if you have seen that application, the Uber, it normally calculates sometimes, okay, this is the longest, you can take this shortcut here, the shortest path, and so on. Search engines like Google use algorithms to index and rank web pages. Normally, everyone here at least has searched something that has never even bothered going to the second page. Most of the stuff you get that has been indexed to the topmost is what you most likely want to see. So in e-commerce, they get to recommend products based on your user preferences. And in AI and ML, we get to analyze data and make those predictions. So the second most overall concept in programming is the variables. Basically, okay, maybe to give you an example, you can, get back. We have the age, then 10, the name 10, and so on. So a variable in programming is like a container that it's more or less like a box in this case that holds a value. The value can be anything. It can be a number, it can be a chain of words, or even a more complex data like a list or object. We'll see what a list is later in Python in our case. The key idea is that the value can change from the name. It's a variable, so it has a varying nature. It can vary during the program's execution, hence the name variable. So these are the key points about variables. Number one, you naming the variables. A variable needs a name so that you can refer to it. A name should describe what the variable holds. For example, age is equal to 25. Age holds a number. So maybe if you define that box of yours is called age, then in our case, we'll expect it to be a number. Then name, these are a chain of characters. We expect maybe, we'll see what a string is basically a chain of characters for a sort, Alice. Then you assign values. You can assign a value to a variable using the equal sign, but So you have created your variable name called score and you have assigned 10. Students in that class is equal to 50. Counties in Kenya is equal to 47. Okay. total population in Kenya is equal, let's say 55.1 million. That's what the gist of all it. So as an analogy, to get you to reinforce the point about variables, think of a variable like a box with a label. Inside that box, you can place different things like numbers, words. You can change what's inside that box as needed, but the label more or less stays the same. Okay. Then we have another thing is the input output. IO, most of the time you're going to refer to it as IO. This stands for input and output, which refers to how programs will interact with the outside world. Example, login page, you enter your name, your email address, and so on. Then you get maybe a response, okay. So input is the data a program receives. Example such as from the user, you uploaded a file somewhere, and so on. Then output is what a data program sends out, what you see on your screen, the files or something like that. So in programming, I/O allows the program to read from and write the resources. There's something you're going to cover in Python. Is going to be, okay, number one is going to be I/O input. We'll see how to read and write to files. Then we see the exception handling and those stuff. So the basic concepts: input, you get data from the user, more or less. When you're entering your digits to some form or some sort, that we can say that's the input. Then, of course, output is the display or the result you get or to your screen or console. As an example, we have the input function here. This allows the program to take input from the user as a string. Then, of course, print function is the what you get out the output. Example, let's run this. So now we are inputting our details here. Then we'll see the output. Okay, so can have my name. Okay, so this is my input. I've inputted my name. Then the output is hello, Jacob. So also another example of an output function, we have the print function, which just basically prints whatever is enclosed in this double quotation mark. We'll see about this when you start working on Python. Then I've shared some additional resources. I'll continue to update this notebook. This is the usefulness of the notebooks. I'll share this link to this notebook so that you can explore it on your own and then get access to these resources. I think up to that point, I am done with the introduction to programming. Then we get to move to the next session on Git and GitHub. Unless there are questions, I'll now unshare my screen as I let Javan proceed.
Hello guys. I'm going to assume there are no questions.
Just a minute, Javan.
Okay.
So before we proceed, Jacob was a little bit fast, but that's okay. Once we are a mixed group, once the other group gets a grasp of this, they're going to see why it will have been prudent to be even faster, because this is language. So probably I could sample. We do not know who the members of this audience are, so as a coordinator, I could probably sample 2 random people. I know some. I know, like my colleague, Dr. Mogire. You could tell us if you have tried programming before, or if this was of benefit. Okay, Dr. Mariam Mohammed. Someone who is able to speak. I want to hear the views. Grow Club.
Hello, can you come up once again, please?
No, we were trying to do a quick census on the audience and what feedback they have on the first presentation before we go to the second presentation. So you can introduce yourself and if you have done programming before and any feedback.
Okay, thank you. By name, I'm Enoch, and it's been a good introductory session. I think it's a well-structured introduction from the girls presented. That could be my feedback. And as we move on to the next, we also hope to see more real examples and practical experiences with the Python program. Yeah, it's from what I see is it's well focused and it's well analyzed because understanding the functions and the basic algorithms with Python will solve a lot now when it comes to the real program that deals with the system that you're trying to work on. Yeah, thank you.
Your background, please, for the sake of your operators that might need your expertise.
Okay, currently I'm a medical doctor in training, but I'm done with my IT, so I'm specialized in information technology as such now. Also training
Exactly.
in Maseno.
Perfect. So we will work. We'll do good work together, Karibu.
It's okay.
All
Thank
right,
you.
over to you, Javan.
Okay, thanks, Dr. Sianyu. My name is Javan Otieno. I'll be taking you through Git and GitHub. So yeah, let me share my screen. Yeah, I hope my screen is visible. Thank you. So before we begin, I'd like to give you a short introduction as to why we need Git and GitHub in the first place. So first we can start with a problem. So Kebaso has talked about the programming languages that have existed from the first to where we are right now. And you've had these hundreds of them out there. And everything you literally do on your devices is a program that someone sat down and wrote. And in most cases, it was not a single person who did all that work. So programming
Javan, you're muted. You're broken.
So you would hear big tech companies like Microsoft or Google, they have like hundreds or thousands of engineers who write code, probably in different departments working on different projects, but for each product you will find that there are teams that are assigned to the product and they have to work together on the same piece of code. So the code that Kebaso has shared with you guys, the samples he gave on taking in input and giving output. So those are very simple examples. In most cases, you'd have code spanning for thousands of lines. Okay, maybe not in a single file, split into different files and such things. So we need to have a way of keeping track of the code that we have and the changes that we're making to it. So that is what Git helps us to do. It helps us to keep track of the changes that we have made to our code. So think of something like WhatsApp. I think everyone has WhatsApp here. So sometimes you wake up in the morning and you find that WhatsApp has a new feature that wasn't there before. So all that is powered through Git, because you'll find that there was an engineer or a team of engineers that were assigned the task of programming that feature. And once they were done, they gave it to the public to use. So that is one of the functions of Git and GitHub. So first, we have said that maybe I can go to the presentation that I had. So a lot of this won't just be presentation. We'll do a bit of practical so that we can get some hands-on on Git and GitHub. So let me present this. Yeah. So I've said that Git is a version control system. So it just keeps track of the versions of your code that you currently have. Yeah. GitHub, on the other hand, keeps those versions or whatever Git has done for you, keeping track of your code and the changes you made to the code. GitHub simply stores that in the cloud. By cloud, I mean some servers that belong to Microsoft. So when they're somewhere in those servers, everyone can access them. Everyone in your team can access them. So we'll see how that works. I'll give you an example of how that will happen. Yeah, so I've talked about what Git is. So for Git, for you to use Git on your machine, you'd have to install it. So maybe I can just remove this and go to Google. If you just search for Git, the first link that will pop up is probably where you should go, and you can download the latest version for your operating system. I'm currently on Windows, so it suggests Windows for the download. For people on Linux and Unix, I think Git is probably in your system, but if it isn't, you'll probably get it from here. So all you need to do is download it and go through the normal installation process. Something else I wanted to show is, if you come to the documentation here, you can get references. Before the references, there's a few videos here you might want to look at. Then we have the reference manual. So I'll talk about some of these commands that are here, but as you can see, the list is a bit big, but don't worry, because a lot of these are things you won't really have to use daily. There's probably like 5 commands you probably need to know. The rest you can always look up. Yeah, the rest you can always look up as you write code. So there's that. So once you have Git installed, you'll get something called Git Bash. So Git Bash is just a terminal that you use for Git, though we won't really use it in this example, but it is good to know that you will have that. So we've talked about Git and where you can get it from. The next tool I can maybe introduce to you guys is something we call Visual Studio Code. Visual Studio Code is a code editor. It just allows you to write code and save the files and things like that. Is that a question? Oh, okay. So you have Visual Studio Code. So if you just search for Visual Studio Code, you will get it. Though there's a disclaimer. If you search for Visual Studio is something slightly different. So you can see they're both from Microsoft, but they do two different things. So you can see Visual Studio is, I'm going to make a bold move and assume this is purple. But yeah, so Visual Studio is blue. Visual Studio Code is blue, and this is what we want. Visual Studio is an IDE, as they have said. An IDE just stands for Integrated Development Environment. So an IDE is a specialized kind of code editor. So it was built for things like C# or Visual Basic. Those are programming languages that are used by Microsoft mostly when you're building desktop apps or using C# for the backend. Anyway, so you have IDEs and you have code editors. IDEs are just specialized. These are not the only ones you have. You have like other ones like or I don't know, IntelliJ for different languages. So IDEs are usually specialized for specific languages or a group of languages, but code editors allow you to write code in any language basically. So it won't have specialized tools for the specific languages, but in most cases, you can add in plugins or extensions so that you enrich the features that the IDE gives you, the code editor gives you. So yeah, so for Visual Studio, you'll also just come to their website, Visual Studio Code, that is. Come to their website and download it from there. So I already have mine downloaded. The last thing we will need is a GitHub. Maybe I can open it from here. So if you go to github.com, we say GitHub basically allows you to put code on the cloud somewhere so that other people can access it. Or even you, if let's say you had you wrote your code on your laptop, and then you had to leave your laptop and had some other device remotely, you could also access your code from GitHub directly. So you'll just come create an account from github.com. For those who do not have accounts, the sign up process should be pretty straightforward. But if you guys have any challenges signing up to GitHub, you can always reach out and we'll guide you. Yeah, so I think I can close this tab. So we've gone over the tools that we'll use for this session, or that I will be going over for this session. Then next, we can talk about some terminologies that you will hear people throw around when they're talking about Git and GitHub. So for Git, we've talked about version control. There's something called a commit and a branch, which I will talk about in a few. So for then there's the repository. And now I think we can start from repository. A repository in this case is just a fancy word for a folder that Git is tracking. So if you put Git in a folder, that folder becomes a repository. So what I mean by putting Git in a folder, in quotes, that is, so we'd have, maybe I can open Visual Studio Code. I'll create a new folder and then initialize Git from there so that we see what that will look like. So here on the files, I'm going to, let me just open a folder, then I'll create a new one from there. I think I can create a new folder, say Git basics. Then I'll select that folder and it will be opened. So now we have our folder. When you install Visual Studio Code, this panel will be probably on this side, but it works exactly the same way. And you'll probably not have a lot of these things. These are just extensions that I installed, like I said, to enhance the features that Visual Studio has. So if you want to install extensions, you can come to the extensions tab. Maybe in this case, you might need a Python extension. Yeah, this one by Microsoft. So all this extension will do is whenever you're using Python, Visual Studio Code will be able to notice that this is Python, and if you maybe make some errors in your code, it will kind of help you notice them before you start giving up. But yeah, so we have your extensions, you have your files. So this is the files explorer. So we just have a folder that has nothing in it. We can create a file that you can, so that you can look at it. So maybe hello.py. So for the bus, we talked about source code when you were talking about programming. So source code basically is the code that you are writing. So for Python source code, we have files that end with a .py extension. Same way you have .pdf for your PDFs, or .png, .jpeg for images. So for Python code, you have your .py. So yeah, so I'm going to do a simple print statement. A print hello world. Print hello world. So we're going to assume that this is a big project and you have many folders and files in here. And we have to at least keep track of what you have done. You know, for people who've used Google Docs or Microsoft Word, sometimes you might have written your draft for, let's say, a proposal. Then you want to make changes to the proposal, but you also don't want to lose the one you currently have. So you start coming up with creative ways of naming the file. Then you have things like this. Let's say your proposal was let's say you'll name the first one proposal. Then you start proposal 1, proposal 2. You keep making copies with creative names, and you end up with things like final and final. But so now Git relieves you from all that by allowing you to keep track of only the things that have changed, so that you can always go back to a previous version if you need to. So this is code that you have written. It is not being tracked by Git currently. It's not being tracked by Git currently, so it's just a normal folder with a single file in it. Maybe I should run this, but then before I run this, I've realized you will need to have Python installed. So we talked about Python being a high-level language from the previous session. And we said that computers basically just understand zeros and ones. So whatever programming language you're going to use, it has to be transformed into zeros and ones. So Python is the same. So when you search for Python, you can go to your downloads and download a suitable version. So maybe you can just download the version 3.13, which will work. Okay, so there is only one catch. Let me okay, as that is downloading. So when you have your code, you have to have some software that will convert your code written in English into zeros and ones. So this Python interpreter that we have, so what we just downloaded is an interpreter. So the interpreter, all the interpreter does is it converts your nice looking English code into zeros and ones that the computer can understand. So yeah, the download has finished. I want to show you, there's usually a step here. When you first get to the install page, you should check the box that says add python.exe to path. That is an important step. Then you can just install from there. Yeah, so all I wanted to show you is this step. So once you have Python installed properly, so once you have Python installed properly, you will be able to run the code that I have just shown you. So all this step of installing Python and Visual Studio is only necessary when you're running code locally on your machine. When you had the Colab notebook, from there you can just run Python from the cells, because the Python is already installed there. So when you're running it locally, you'll have to go through this installation process. Also, maybe I can show you how to open a terminal for the first time so that we see. So if you can just come to your terminal and new terminal, or you can use the shortcut they have provided. So the Control-Shift-tilde. So that also works. So this box that appeared here is what we call the terminal. I talked about Git bash being installed when you install Git, so that's why I have bash here. But down here you can see there are a few others. Maybe in your case you'd have, for Windows that is, you'd have command prompt and PowerShell, maybe Git bash. So all of them will pretty much work the same. There are differences in terms of a few commands, but for the commands that I will use, they should work for whatever terminal you will be using. Yeah, so now we have to tell Git, we want to tell Git that it should keep track of this folder. As you can see, the folders we are currently in is /GitHub /Git basics, which is the same folder that we have here. So I can type in Python, then the name of the file. If you press tab, if you start writing the name of the file and you press tab, it should autocomplete for you if there are files with that name in your currently open folder. So before we run that, to confirm that Python has been installed correctly, you can just write Python alone, and you see that you have Python 3.12 installed. If I wrote the print here, you can see that it takes in input and gives out output immediately. So something you're going to probably not use as much, but ideally this is a shell that you can write Python code if you want to test something quickly, even maybe some maths, and it works. So to get out of here, you'll just write quit and opening and closing bracket. We will talk about what the brackets mean when we're doing functions in Python. But ideally, for you to run your Python file, just write Python hello.py, and you can see it has printed out the output that we wanted. So this file is valid Python and it works. But now, if I was to make changes to this file, I wouldn't know what exactly I changed and what the previous version had. So that is what Git allows us to do. So I'm going to write a few commands here. Maybe I can show you from the references. Yeah, so getting and creating projects. So there's two ways to go around it. I've seen config. So before, when you install Git for the first time, you will need to tell Git your username and email, so that because Git, apart from keeping track of the changes that were made, it also keeps track of who changed what, so that later on you can easily track what changes were made and who made those changes and when those changes were made and such things. So maybe I can just Google the exact command so that so how you tell Git is through these two commands. So you'll probably type git config 2 global user.name, and then you write your name in quotes. And the same thing, but you change the name to email and you give your email address. So those are two important steps when you just installed Git. Though these are steps that you'll only do once. So we can go back here. So we were on this other tab. So there's two ways. So there's the Git init, which is what you're going to use first. And then there's the Git clone, which we'll talk about when we move to the GitHub part. So for the Git init just is a short form for initialization. So it is just a way to you can see it creates an empty Git repository, or you initializes an existing one. So we talked about a repository, and we said a repository is just a fancy word for folder that Git is keeping track of. So all we have to do is type git init. So all these things are just the different options that you can use to change how the command works. This is okay. This is the documentation. So in case you want to know what these different options do, you can read about them. Like if you wrote it init -q or -- quiet, it will only print errors and warning messages. All other output will be suppressed. But in this case, we'll just use git init as it is. So you can see that it is telling us it has initialized an empty Git repository in this location. So we are currently in users, HP PC, GitHub, Git basics, and then there's a .git folder that is usually hidden. So you won't see it appearing here, but it is there. Maybe I'm going to try something. So ls is a command that can be used on git bash to list the folders and files that are present. The -a is an option that tells it to list all of them. If I wrote ls alone, you can see it's not showing the .git folder because folders that start with a dot are hidden by default. So -a stands for all, tells it to list all the files and folders, including hidden ones. So this ls command works on bash and PowerShell. If you were using command cmd or command prompt, you would type dir. It's not listing all of them, so maybe I don't know if it has the -a. Okay, that isn't working. But yeah, but dir is supposed to do the same thing ls is doing. Yeah, but then it just shows you the file and maybe how big it is, a timestamp of when it was modified, and things like that. But mostly you should probably, okay, this is a preference because I mostly use bash or PowerShell. Maybe you can try on PowerShell. The hyphen is not working. So
The
okay,
demo is a
so
live
apparently,
demo.
using shells you're not used to. But anyway, so apparently -h in PowerShell is used to display the hidden folders. So .git has shown up. But anyway, so you can probably use git bash if you want to be on the same page. So we've seen the folder is hidden. So this folder is what keep tracks of the different commits that were made and who made them. So all that information is stored in that folder. You don't have to worry about that folder again. Just know it is there. So if you guys have noticed, this file has changed. I think it was white, but now it is green, and you can see there is a small U here. And if I hover over it, you can see it is telling me that this file is untracked. So yeah, so we've initialized Git for now. we've seen that now Git is aware of this folder. So now this Git basics folder has graduated to be called a repository. And we have a single file that is untracked. So maybe okay, maybe I can ditch these slides for now. So we've talked about Git init. The next basic commands, which are probably the ones you will use most, so is something called git add. So git add basically tells Git that you should now keep track of this specific file or these files that I have listed. So if you go back to your terminal, you can type git add space and then a list of the files that you want to add. So in this case, we have hello.py. So if I type enter, you can see the U has turned into an A. It's telling us that this file has been added. So if you also notice, the third icon here is called source control. So it deals with everything we've been doing on Git. So you can see that it's telling us that hello.py is in a staged changes state. Maybe I can create a different file so that we see what it probably was in before. Maybe you can duplicate this. So here you can see that these are changes and it is untracked. We added the hello.py with the git add command. But if you come here, if you want to use your mouse, you have your plus button. Plus, it's easier to remember that plus means addition. So you're basically adding the Git. So the file that is. So if I click on the add, you can see it has moved to the same place that a hello.py is in. So now you can see that there's different stages that a file can be in. Maybe I can get a whiteboard. That I show you how this thing looks like. Nice. So we basically have three stages that your file can be in. So this first box, you can think of it as the working directory. Directory is also another word for folder. For people who are familiar with Linux, for some reason, Linux users like to use different terms for the same things. Anyway, so we have your working directory. We have a different box called a staging area. And then lastly, we have I'm going to call this what? Okay, I'm going to call it commit. Probably not what it should be called, but ideally this these are this is just a way to illustrate what is happening. I hope the font is visible. Maybe you can try making it a little bit bigger. So when you first create your file, it's in a working directory. So we have changes made to the file. So maybe we had our hello.py here initially. Then we moved it to a staging area using the add command. So once we did git add to this file, it moved to a staging area. So now our hello.py is currently here. And now we want to move it to this other section. But before that, I want to talk about what a staging area basically means. We said a working directory is just files that you're currently working on. So this happens when you probably have changes that you're not fully done with the code. So maybe you're actively writing that code. Then once you add it to a staging area, that is basically telling Git to prepare to store those changes permanently. So you can think of it maybe as a simpler analogy is maybe something people are familiar with is a stage or a bus stop where a lot of people come and wait there for a bus. So if you think of this as a bus stop, the files are here waiting for the bus to arrive. Once the bus arrives, which in this case means you are satisfied with the changes you have made, you can commit them. Committing is basically putting everyone in that bus and sending them to wherever they're going. I hope that makes sense. But anyway, so the command we'll be using in this case is commit. So maybe I can write it here first before we explain more what it is. So if we are to look at the reference, we have, okay, I've skipped this too. Maybe I can show you what git status will show you. But if you type git status, it just tells you, it gives you a summary of what is happening in your git commit. You can see that the changes to be committed are these two files that are new files. So it's just a summary, which is basically what this Visual Studio Code has provided with you here. So that's why I skipped the git status. So yeah. So next we were supposed to do the git commit. Maybe I can unstage one of the files. And we look at git status again. And you can see that we have one untracked file and we have one file that has changes that are going to be committed. So let me clear the terminal. So now when you type in the command git commit, you have to give it a message, something that you can use to remember what changes you made. So in this case, you're going to use the -m, and then in quotes, you're going to write your message. So in this case, we're going to say something like added a print statement. So that is the change that you have made. Once you press enter, you can see that we have a commit. So this is the ID of the commit. And there was one file that was changed and one insertion. So we inserted one line into that file. So each commit has a unique ID such that you can always keep track of the exact changes that you have made. So you can see here that the commit has appeared here, down here. So we have you can see it was done by me on December at 7:15 p.m. This is the commit message. One file was changed, and this is the ID. If I copy that and paste it, I have typed the wrong thing, but anyway. So this is the full ID. Here you just see a shortened version of that ID. Maybe I should wrap it in quotes so that my Visual Studio won't think. So we have, this is the full ID, but you can see there's the shortened version here. So usually Git doesn't really care if you give it the full ID as long as it won't confess that commit for any other. So this would be interpreted as this for, if you were to use the ID somewhere, there are a few commands that you can give the commit ID, which I will talk about, but ideally you don't have to have this entire string. You can just have the first few characters. But anyway, so we have our commit, our first commit. So now I should explain what a commit is. So I talked about Git being able to keep track of versions of your code. So a commit just basically tells Git that at this point you should keep track of what the file looks like right now, so that when you make other changes, you can always go back to what it looked like at that point. So for people who've played games, especially games that have maybe a story mode, when you're playing your game, let's say, and you get to a point, maybe you've done 3 missions so far, and then you shut down your machine and you come back to play tomorrow. The computer remembers that you had done 3 missions and you'll probably start from the last mission you completed. So it might not remember exactly maybe what location of the game you had reached or something of the sort, but it will just give you to the last saved the last saved mission. So that is what a commit does. So now our hello.py is here. The other file we had, I don't know, I don't even remember what I named it. The sample.py is still in the working directory. So I'm going to move it from here to the commit area using the Visual Studio without using the terminal, because sometimes people see the terminal to be intimidating. So when you're using the Visual Studio Code to do this, all you have to do is stage the change, and then up here you can see that there's a provision for a message, so you can write the message that you want. So we can say maybe added sample.py, and then we commit the change, and that is it. So if we look at Git status, you can see that there is nothing to commit and the working tree is clean. because there's no changes we've made that have not been committed. I can see our 2 commits. This is git lens. I'm not sure if git lens is available to people when they install a clean VS Code. If it's not there, it's probably something you can install from the extensions. Yeah, git lens. You can install it from there. It gives you a good visual view of your commit histories. But anyway, so we have 2 commits. So you can see that the first commit was down here at 7:15. The next one is at 7:20. And you can see that they are linked together. So ideally, if let's say we realize that this file or these changes should not have been made, we can go back to what the code looked like at the point that you committed this. So you can go back to this stage. I've clicked on them and you can see this is basically the differences that are there. So initially there was nothing, and then we added like 3 lines. On the first line, we have the print hello world. So those are the differences that we've made. So up to that point, are we okay? Nice. So next I will go into what how GitHub fits into this whole thing. So now all these things we have done have been done locally. So this has been local. Locally just meaning on your machine. But now we want to move it to the cloud. Basically GitHub. So all you will do is once you have your GitHub account, you can log in. We'll create a new repository with this plus here or this green button. So you can see that the owner of this repository will be me, my GitHub account. You can call it this. So you have the option of choosing whether it should be public or private. Public just means everyone on the internet can see the repository. Private is just people that you choose. So I'm not going to add any file to it. I'm not going to add a git ignore. I'll talk about what this means. No license. I'll just create the repository. So now you can see that it's telling us that we can create a new repository with the command line. So this goes through the process of doing the git init. It creates a file. First, it creates a file called readme.md, does the git init that you had done, the git add that you had done, the git commit that you had done. Now, here it's creating a branch, which we haven't talked about, but we will. Then it's doing something called, it's adding a remote repository. So this is the next step that we want to talk about. So now, but before that, so we can see that this already has steps that we have completed. So what we want to pick is this last bit. So we can just copy this. And now the git remote add origin and this URL, all it does is it tells Git that you have a remote repository somewhere. So somewhere that once the changes are made, you should send those changes to that place so that either you or your colleagues can access the code. So I've copied this command. Maybe we can copy them individually so that we run them one by one. So that's the first command that has been run successfully. So origin is just a nickname we're giving this URL so that each time we are talking about origin, it knows that we're talking about github.com/javan/git basics. So you don't have to keep repeating this URL in full. So we are adding a remote repository, remote add. We give it a nickname, origin. Origin is just a convention for GitHub. So that was the first command. I'm going to run this second command, but before that, I want to show you why we are running it. There's a command called git branch. Already you can see that we have a branch called main. A long time ago, the default branch that Git created for you was called master, the master branch. But then some people felt like it had slave references because of the master and slave. So it was changed, and now people use main. So I guess Git also changed it in the source code. So that is what this command does. It just changes the branch to be called, renames the branch to main for cases that maybe your branch is not called main. So there's that. So Git branch has a lot of usage. Maybe you can see that -h is usually something that prints out a help manual for commands. So if you have a command and you're not really sure what it does, you can, or how to use it, you can put the -h and you will see like a summary of the options that you have and things like that. So we saw capital M, which just moves or renames a branch. So that is what the -m did. So we'll see some of this. Okay, we'll probably not use the branch command a lot because the thing with Git is a lot of these commands you can be combined in different ways to do whatever. Okay, maybe something you would have done with 2 or 3 commands, you'd find that there's one single command that can do the 3 steps. So we'll talk about that in a bit. The last command that was there is git push -u origin main. I will copy this. Though there was the option of copying all this once and pasting it on your terminal. So there's that. So now you can see that you can, okay, there's some output that has been given out here, but maybe what is important here is that we have a new branch that from main that was taken to main somewhere else. So the branch main was set to track origin main. So all we have done is we have connected our main branch to the main branch that is in GitHub. So the git push command just takes your changes and puts them to the cloud. Takes your changes and puts them to the cloud. So maybe for the whiteboard. So the cloud here can be GitHub. GitHub is not the only remote repository storage that we have. There's things like, I think, GitLab, Gitbucket, but GitHub is the most popular one. So that's what we are probably going to use. So for you to move from your local to your cloud, we added a remote, and then we added the remote branch. Then we did the git push command. So the git push -u thing, you probably only do once. The -u part, that is. So -u just tells Git what branch you're pushing to. It talked about origin being an alias for the full URL to GitHub. So instead of writing http:/github.com, you just write origin because you give it an alias. So -u just tells Git that you're pushing to set there's something called setting the upstream. You don't have to worry about what that means. You just know that whatever command GitHub will give you does all this. So it just tells Git that you should connect this main branch to the main branch that is in origin, which is GitHub. So that is what we have done. So next I will talk about, maybe I can use this. Next we can talk about cloning, because this is the second option of getting and creating a project. So on GitHub, we said maybe you can refresh this so that you see that our files are there, the hello.py and the sample.py. Anyway, so I'm going to search through GitHub. We're going to go to a repository called Llama. So there's the Llama by Meta. So I'm going to, as you can see, we have like, we have a few files here, the Llama folder. Here you can see there's the model.py. So this is basically Python code. Llama is, I'm going to call it a large language model by Meta, or formerly Facebook. So this is like their version of ChatGPT. I think ChatGPT is more common. So this is basically Python code that people have been writing, but it's open source. Open source meaning whatever code is there is free for people to view the source code and modify and do things with it. Okay, maybe it's licensed, so maybe there's a limit of what you can do to it, but
It's licensed if you have more than 700 million users.
yeah. So that when you get to that point is when you have to pay Meta for it. But ideally, you can play around with this one. So I'm going to show you how I'm going to use this repository as an example of how you would clone something. So the two options we had of creating a Git repository was to initialize one or to clone. So I'm going to, so now I'm in the repository. You have the code part here. Here you have a link that you can copy to clipboard. So I'm going to do what? I'm going to write the cd. Cd command is basically a way for you to change directories or folders. It's the same as clicking on a folder somewhere on your usual interface. So if I do cd dot dot, it takes me to the parent folder. So right now I'm in Git Basics. You can see that I'm no longer in Git Basics, but I'm now in the GitHub repository, the GitHub folder. So I'm just going to write git clone and then paste the link I just copied from GitHub. So the reason I've gone a folder behind is so that the Llama folder does not clash with the Git Basics one. So maybe I can type enter. You can see it has finished cloning. So maybe I can open the folder. Or rather than removing this, I can open a new window. So we'll just open the folder from here. Yeah. You can see Llama is here. We'll open it. So now we have the code from GitHub locally. So we, if you can remember, we saw the models.py from there. And we could also see there was a tokenizer.py. We'll talk about what tokenizers are as we proceed with the machine learning courses. So at the end of it all, you'll be able to understand what these things do. But the point here is that we have been able to take code that was on GitHub and brought it to our machine locally so that we can play around with it. So that is the git clone. So now there is a new problem that will probably occur here, in that now that we have a repository that a lot of people are working on, what happens if, let's say, I changed some code, maybe I can minimize this. Let's say I was working with someone else and someone saw that world was not maybe a good option and they wanted to say, hello Python. And they changed that piece of code. Now, Git will keep track of that change. And at the end of it, all those changes will probably have to go somewhere. So yeah, as you can already imagine, if you have 100 people working on the same piece of software, there are bound to be conflicts where someone maybe saw there's a better way of framing this maybe algorithm, and they changed a piece of it, and someone else changed the same piece maybe with something else. So there's usually some conflicts that occur whenever there are changes to code. So there are ways to deal with that. We won't. Okay, maybe I can show you how to get newer changes from somewhere else, and then we'll maybe try and create a conflict, a small one, so that we see what happens. So we're going to simulate someone else creating a repository and doing something to it. Okay, not creating per se, but changing code that we had written. Yeah, so this is the repository we created. Maybe someone working on the project with us went and changed this file. I'm going to edit it from here. Maybe just to hello. Then I'm going to commit these changes. I'll commit directly to the main branch with a commit message of update hello.py. So now this file has changed to hello only. So now if someone else has changed code somewhere and you have to, maybe I can close this for now. I don't think we'll need it. Yeah. So now someone has made changes. So whatever code we have has become outdated. And you can see that already Visual Studio has noticed that. You can see that there is one arrow coming down and an arrow with the number 1 coming down and the 0 going up. So the 0 commits that we have made that are not on GitHub, but there is one commit on GitHub that we do not have. So the one just tells you the number of commits that are there. So the command that we will use to bring those changes to our local machine is something we call git pull. So if you just type git pull, it will pull the changes from the remote repository on whatever branch you are currently on. So right now we only have one branch, which is the main branch. So all it will do is pull those changes. So before you pull the changes, I want to create a conflict. So this was hello.py. So I want us to change the same exact file locally. Okay, maybe I can just discard the changes I made to sample.py. You can also see from here it's telling us that we should sync changes. So we can change this to hello Python. So to simulate that someone else has changed code and you have also changed code. So we'll go through the process of adding it and committing it. So maybe changed world to Python and I commit. So now we can see that we have both changed the same piece of code. So if I try to, this sync changes simply does a git pull. So maybe you can just click on the sync changes. You can see this action will pull and push commits from and add to the origin main. So going to press OK. Now we can see that it has given us this, which is basically a comparison of the two files. Maybe you can click resolve in merge editor. Then you can see that on the incoming, the one coming from the remote origin, we only have hello, the one on GitHub. And the one we have locally, we have hello Python. So you have the option of accepting the incoming or accepting the current. So based on whatever you want to be the true version of that code. So what was there before is hello world. So we haven't accepted any yet. So maybe let's say the version we want to keep is the hello Python. So you can accept that. And then if I complete merge and sync changes, okay, maybe it's telling us we have not completed this. So maybe I can so let's try git pulling. Oh, sorry, are not supposed to be here. So now we're being told we haven't completed the merge yet. We clicked the git merge. Huh. This does not happen normally. So I'm going to remove these files. Maybe before I remove them. Now this is the debugging part that Kibasa was talking about.
So you wanted to demonstrate the collision that will prevent them from merging.
Yeah, but for some reason our merge editor has failed us. Okay, you can see the hello Python is. Maybe I should just refresh my Visual Studio. Hopefully that's. Okay, I don't think it has helped. Yeah, maybe we can do it. Yeah, probably there's a file that has not been closed that is preventing Git from noticing that we've fixed the conflict. But based on what I had done, okay, maybe we can say we merged with main. So that was it. So we've basically now made another commit. So you can see from the tree that we had our first commit, our second one. Then from here, this commit was done on GitHub, and this commit was done locally. And now we have brought those two changes together. So this new commit, the merged with main, is the current version of the code. So if we are to sync those changes, it will push them to GitHub, and we will have that the Hello Python that we selected, we accepted as what we will have here. So if I was to refresh this page, you can see we're back to the Hello Python we made locally. Yeah, so maybe the last thing I want to demonstrate is a concept called forking. A fork is basically a way for you to, we've seen what cloning does, which basically is taking changes from a GitHub repository into your local machine. So forking is basically taking a repository that someone else owns and making a copy under your account. So maybe we can go to we are on GitHub. So maybe we can search for what? Let me think of a popular open source project. Maybe Mami. Yeah, there's a repository called Mami.js. So whatever this repository does is not that important right now for our case. Just helps you draw diagrams that you can use to describe what your software looks like or how your software works. But anyway, so this is an open source project, and you can see that it has like 590 contributors, and we have like over 61,000 people that are using it. So you can see we have 6.7K forks. So we're going to also create a fork of our own. So all you have to do is click on the fork button, create a new fork. So under our account, under my account, we have the Mermaid. So we can just create the fork. So this process usually happens whenever you want to create your own version of some open software. Once you're done with that new version, you can recommend that those changes be added to the original repository. But so now we have, under my username, we have the Mermaid repository. So assuming that this is a popular software that I want to make changes to, maybe I'll change something simple. Maybe we can change the README file. I'll just edit it so that this is something called Markdown. It's just a way for you to describe what text should look like. So whatever we are editing here is what will be viewed as this. So that is all it does. So maybe we can change this Mermaid name to I Love Python as a demonstration. Then we commit the changes. We're committing it to the development branch. So you can see that right now the README says I love Python. So what will typically happen is you will make changes to your code on a fork. Then once you're done with those changes, maybe I can go back to what the repository looks like. You can see that it is telling us that this branch is one commit ahead of the Mermaid.js/Mermaid development branch. All this helps you to do is you can make changes, you can play around with this code without affecting the original code that Mermaid.js owns. So all those contributors you saw there made a fork of the repository, played around with a few things or added a feature or two. Then once they were done with those features, they created something called a pull request. So all you do is you come here, and so there's two tabs, the contribute and the fork and the sync fork. Syncing happens when the original has some changes that you don't, so you're bringing them to you locally. So locally in this case meaning your fork. So you sync changes. When you have done changes and you want to take them to the original, you contribute. So in this case, we'll contribute and we open a pull request. We won't finish the process, but ideally you can see that it is able to merge, meaning there are no conflicts. Then all we are doing is you're merging, we are opening a pull request to the Mermaid.js development branch from my account, Mermaid Development Branch. So you can write a title, you can, they have created a template. So most of the time this will be empty, but they've created a template that helps you describe what you have done. So you can write the things you have done. So you can see that it is telling us to be sure that you've read the contributions guideline. So in most repositories, there's usually a guideline of what you should do so that you don't just throw code there and expect it to be merged. So once you have obeyed the rules that have been set there by the repository maintainers, you can create your pull request and it will appear in the pull requests tab. So you can see that all these are changes that people want to be merged. And you can see that some of them have been labeled to have bugs. Some of them are type enhancements, but as you can see, there's a lot of them. Some of them are closed. Once you merge a pull request, so once you've created a pull request, the maintainers of the repository will merge it and then it will be closed. But they can even close it without merging it. But yeah, so that is, I think, it for today. I have covered a lot of things on Git and GitHub and how they are used and why we need them. So I guess maybe for the next maybe 5 minutes, if you guys have any questions, you can ask so that we answer them.
Thank you, engineer. Any questions from the audience? All right. I think maybe today's content was very basic to the audience, but at least it's good that we cover everything so that as we go towards the more complex concepts, everyone is carried on board. All right, over to you, Jacob.
Okay. Thank you so much, Javan. Okay. That was the first iteration of the primer series. We are going to have another session tomorrow, then an open science 101 on Friday. Basically, for whatever Javan has covered on this Git and GitHub is going to be used in our course for the remaining part of the summer school. Those things, that was why it was essential we bring them right now. You continue to familiarize with them. For that, unless there are any other questions, we can adjourn the meeting.